Korea 1987, Mexico 1989, European Union, all countries, 30 countries, 1993, Brazil 1994, Russia 1999, India 2000, China 2000. So, and India, though it was introduced in 1991, nobody cared. But later on, Supreme Court intervened and then started implementing the Euro Bharat standards from 2000 onwards. Then working principle of autocat, how the autocatalytic catalytic converter will work. See, when the carbon monoxide is emitted, it will combine with oxygen, gets converted to carbon dioxide. And the unburned hydrocarbons, benzene or toluene or methane, ethane, anything, they will get oxidized while combining with oxygen into carbon dioxide and water. The nitrogen oxides, which is, you see, all the red ones are extremely hazardous, toxic. On the other hand, the products are not so harmful. Particularly nitrogen is not harmful at all, and water is not harmful at all. So this is how. There you can see there are two compartments. One is the oxidizing reduction compartment. The second one is oxidizing compartment. So because the car engine operates at 350 to 650 degrees centigrade, emit harmful gases such as carbon monoxide, nitrogen oxides, hydrocarbons. And in order to protect the environment from these toxic gases, all the modern cars are equipped with a catalytic converter, as already said. So this is called a three-way catalytic converter, which is a standard feature of all the automobiles today. And I told you there are two compartments. So the first one is a reduction compartment, and the second one is an oxidation compartment. In the reduction compartment, no, nitrogen oxides, they can get converted to harmless nitrogen. In the oxidizing compartment, carbon monoxide and unburned hydrocarbons, they get converted to less harmful carbon dioxide and water. So this, while helping forward the above reactions, as the engine operated at a very high temperature, the autocatalytic converter throws out significant quantities of platinum, palladium, and rhodium into the environment. When I wrote this, when I published that in Hindu, the Maruti immediately wrote back that we are following strict environmental protection protocols. No platinum, palladium is thrown out from our vehicles. 2003, even Fiat also responded that way. But it was not true. I didn't argue with them, so I just kept quiet. And then later on started publishing. The harmful effects due to high temperature chemical reactions. As I told you, in one hand, autocatalysts are very useful. And on the other hand, they are throwing harmful platinum, palladium, and rhodium into the environment. And in fact, these two authors, Lee and Bhatnagar, in 1988 itself, they predicted that you are making a noble metal autocatalytic catalytic converter. There is a chance of these things coming out and getting spread into the environment, and they get accumulated in the streams, rivers, lakes, and their sediments. And because of the further microbial biotransformation in the streams, they may prove to be toxic to humans. In 1980 itself, that means 40 years back itself, it was predicted. And you see this, I forgot to show. See, if you take the autocatalytic converter and do the XRF, you will see platinum, rhodium, palladium peaks, and there is also aluminum and zirconium coating. And what are the, other than the vehicular inputs, what are the other sources of platinum, palladium, and rhodium? So natural sources, volcanic, when the volcanic emission takes place, a lot of PG is thrown out. And also, when you have a meteoritic fall, the extraterrestrial materials are very rich in platinum group of elements. So it will not be so much abundant, but definitely the platinum group element rich material will fall down on the earth. And in PGE mining, if not in India, if not today, some other time they will start. But countries like Russia, Canada, South Africa, a lot of PGE mining, a lot of pollutions are being reported uh, in the surrounding areas. Industry, all the ammonia making, sulfuric acid making, nitric acid making industries, and also so many other petrochemical making industries, they use platinum palladium as catalysts. So their effluents will have definitely platinum and palladium. And vehicular inputs, we have already been talking. Then healthcare, platinum drugs are being used to cure cancer patients. So their blood, their urine will have platinum. Then e-waste, I told you all our computers, all our modern electronic gadgets will have platinum, palladium, and rhodium in them. So when you throw out, platinum is getting into the environment. The recycling operations also, but they generally recycling operations will be very crude, and there is every chance that these metals are getting into the environment. In addition, not only the platinum, palladium, and rhodium, but there are a lot of other elements, toxic elements like lead, thorium, rare earth elements, and other elements are also getting, a lot of inputs from the earth sources, and also agriculture insects. For example, zinc a lot of zinc is going into the soils through pesticides as well as fertilizers. Rare earth element fertilizers are used to increase the yield of the crops. So like that, a lot of elements are getting into a lot of toxic elements are getting into the soils, water, and sediments. And these are the major sources of PGE, exclusive PGE. Even the upcoming lithium batteries, they are coming in a big way, mind you. So they will also have a lot of platinum. They boost the performance of the battery, lithium-ion battery for extra hours. So a lot of platinum, palladium will be there in lithium batteries also. When their lifetime is over, when it is thrown into the environment, a lot of platinum, palladium is going to come out into the environment. Sometime back, I have divided all the elements, trace elements in the environment into 4 groups. The first group are very toxic, like cadmium, mercury, lead, etc. They are toxic at all concentrations, and we should not inhale them, or we should not have them in our bodies. The second group are less toxic, but still they are toxic if they are present in more than permitted concentrations, like arsenic, antimony, bismuth, etc. The third group are essential, like copper, cobalt, iron, selenium, zinc, etc. But even these essential elements, if they cross a limit, they are toxic. And on the fourth group, like rare earth elements, platinum group of elements, we don't have much information, and we don't have even regulatory limits also from the World Health Organization. Now people are working on it. And even the medicines, there are actually, these medicines are the elemental impurities of these elements like platinum, palladium, rhodium, ruthenium, etc. There are limits for concentration in the oral exposure, parental exposure, and which I have given in my Trends in Analytical Chemistry paper in 2016. Yeah, coming to the health effects of platinum, when in fact the people have realized the remarkable properties of platinum, its ability to inhibit the division of living cells. So discovery of this property in 1960s led to the development of platinum-based anti-cancer drugs, which first became available in 1990s and are now used to treat wide range of cancers. These are the major drugs, platinum drugs: cisplatin, carboplatin, oxaliplatin. The above 3 drugs are used to treat almost all, half of the people who are receiving chemotherapy for the cancer. There are also other drugs which have got the FDA approval recently. And not only these salts, but these salts are used for treating the cancer. But the other salts like platinum chloride and nitrate, etc., they cause severe health problems such as DNA alterations, cancer, allergic reactions, damage to organs, etc. And how the platinum palladium is thrown into them? What is the mechanism behind? Mostly it is mechanical erosion, thermal, because this engine operates at a higher temperature of the 400 to 600 degrees centigrade. And also some chemical reactions are also possible. As a result, nanomaterials of nanoparticles of platinum palladium of the order of less than 1 micron are thrown into the environment. And some time back, there was a news item in the Telegraph of Calcutta under UK news. One PhD student claims to have discovered a viable method for getting platinum out of the road dust. That you can imagine how much platinum is getting into the road dust. So the people thought we can mine platinum from the road dust. And today we have 23.24 crores of vehicles in India, and out of which more than 2 crores are registered in 2019 itself. Means every year 2 crores of vehicles are being added to the tally. And in the world, 1.4 billion vehicles. Maybe it is a smaller figure than what it's really, and it could become 2.5 billion which means this particular problem is going to be more and more in future. And you can also see some of the air particulate matter, the road dust, roadside, urban water. A lot of platinum values are being reported everywhere. And PGE, we have actually noticed as high as 500 nanograms of platinum, 800 nanograms of palladium, and 100 nanograms of rhodium in road dust. And those are getting transformed into different species and getting into various plants. And then they are all food items for the birds, fish, etc. They are all food items for us, and we are eating them. They are getting bioaccumulated, bioavailable. And particularly the palladium is more susceptible to become more and more mobile because it forms very soluble complexes with chloride. And ultimately the roadside water bodies are getting contaminated with palladium and platinum rhodium salts, and these waters are drunk by the birds, and then again even the fish also get affected, and the platinum palladium. If you analyze, a lot of papers are also there how much fish is reporting platinum palladium, and ultimately we are eating them and then we are directly getting affected. And in cold countries like Russia, Finland, America, Canada, and some of the European countries, they add de-icer as a to fight the icing. Because if there is an ice on the road, it becomes slippery. In order to avoid that, they add the de-icing agents like ferricyanide, then chloride, sodium chloride, etc. See, the ferricyanide and chloride ions, they immediately attack palladium and then form soluble complexes and become more and more mobile. So this is the summary. How not only the vehicles, the automobiles, but also a lot of other sources are there. As I told you, there are other sources like easy mining, healthcare, industry, e-waste, etc. All they get into the atmosphere, road dust, roadside soils, urban water, sediments, etc. And ultimately they get into the our food, and the atmospheric platinum we directly inhale, and other platinum, palladium, we get through the food. Yeah, we get through food. And then, so you look at they're automatically changing. Yes. Then you see, you look at the city and the country, the Perth, Australia, reporting platinum, palladium like 400 nanograms per gram, 440. Hyderabad reporting 43, and Visakhapatnam reporting 29, Kolkata reporting 551, Mumbai 9.4. It all depends on where you sample. I mean that they may not be representative, but all other countries, even the Kuala Lumpur is reporting very high values, and then Beijing, China is reporting very high, and even Gothenburg, Sweden is reporting very high. Like that, there are a number of studies. These are the values in the atmospheric aerosols. See, Calcutta reporting, then Beijing, very high values. Then Buenos Aires, Argentina is reporting very high value. Madrid, Spain is reporting very high value. And some of the environmental matrices like leaves, I mean the roadside leaves are reporting very high values, 2,500 pg per g. Means 2.5 ppb. On the other hand, you look at the Greenland. Greenland is a pristine area where you are not expected to see any platinum palladium coming from this kind of platinum palladium. So that is 0.01 pg per g. That is a kind of a blank for us. Even Antarctic ice, 0.1, 0.8 pg per g. So there are some background values for us to understand. And the raptors in Sweden, birds in Sweden, egg has more amount of platinum. Blood has 0.29, and feces has, the excreta has 0.72, and urine unpolluted 0.5 to 14, whereas polluted 21 to 2.9 pg, ng per g. Blood plasma unpolluted this much, polluted is this much. After cisplatin therapy, cancer therapy, it is reporting in ppm. Like that, whole blood 0.8 to 6.8 pg per g unpolluted, and polluted to as high as 280 pg per g. So we have taken up studies at NGRI. We have selected some 3 South Indian cities: Visakhapatnam, Hyderabad, and Bangalore. And then we have sampled road dust, airborne particulate matter, soil, sediments, water, wastewater, blood samples from people like traffic police who day in and day out get exposed to platinum. And the epidemiological sampling, how we need to take a lot of precautions, and we can in fact urine, saliva, hair, blood, etc. But we have done only on blood samples. We need to be very careful with the kind of containers we use and storage. And chemical characterization is not very easy. See, though we have brilliant minds everywhere in the country, they are not, in fact, accessible to, they don't have access to this kind of techniques. There is the reason not many studies are. For example, Nagpur doesn't report anything. And Delhi also doesn't report anything. Chennai also doesn't report anything. You have brilliant minds there, but they don't have this kind of facilities which can very precisely determine platinum group of elements at extremely low concentrations. So the techniques like ICP-AES, HR, high resolution ICP-MS, MP-AES, ICP-MS, AES, neutron activation analysis can be used. And we have also the fire assay procedures are the best procedures, in fact, and we have developed fire assay procedures for the determination of because the PG they get distributed in a very heterogeneous way. You need to take more amount of sample. In that case, fire assays methods are more suitable actually. So we need to mix the sample with some fluxes and then heat it at 1100 degrees centigrade. And all the PG are extracted into a nickel sulfide layer. In fact, in nature also that is how it happens. That is how the nickel, PG deposits form. And then it gets concentrated nickel sulfide layer. And that nickel sulfide, because it's very heavy, they settles down and then that will be separated and then ground to powder, then dissolved. And then using a tellurium, we precipitate all the PG as a tellurides, black precipitate, and then filter them and dissolve those tellurides and determine using ICP-MS, MP-AES, and high resolution ICP-MS. These are the 3 papers respectively, which we have published. And as I told you, fire assay methods are the best methods for these. So there are 3 types of lead collection: lead fire assay, nickel sulfide fire assay, copper fire assay. So these we have actually done all these and published a number of papers. Anybody is interested, please send a mail to me or WhatsApp, then I will send you the necessary information. And then advantage of using high resolution ICP-MS. High resolution is, for example, the platinum 195 isotope suffers a direct overlap of hafnium oxide, 179 plus 16, 195, direct overlap. High resolution ICP-MS can very clearly resolve. You can see the hafnium oxide peak and platinum peak are totally separated. So as a result, accurate determination of platinum is possible using high resolution ICP. Most of our determinations are by high resolution ICP-MS. After 2013. So in summary, see, these are the various analytical techniques. If you have at the PG at ppm level, these are the instruments: gravimetry, titrometry, flame AS, XRF, UV visible spectrometry you can use. But if they are at present at Ng per G, only ICP-AES, MP-AES, INAA, GF-AES, biosensors. Biosensors are becoming more and more. For example, Nebraska University, there is a lady professor called Lee, I think. She developed biosensors for each and every element, like copper. You can determine exclusively copper in water samples. Copper biosensor, platinum biosensor, gold biosensor, like that. I mean, they are going to come very soon. The electroanalytical techniques are extremely accurate, particularly with these elements. And still further low PG, means PBT levels, then ICP-MS, HR ICP-MS, ICP, time of flight ICP-MS. These are the methods in general used. And when platinum, palladium, and rhodium are thrown into the environment, in what form it is thrown into the environment, what kind of a wash coat you have along with platinum, palladium. So those things can be observed under microscope using a scanning electron microscope. This is what which model we have, and my colleague Dr. Sharma at NGRI. So we even published some papers using this technique. And more importantly, the determinations we make have to be extremely accurate. You need to calibrate with a good standard, internationally traceable standard, and also run few standards as an unknowns to check the validity of the data we get from the instruments. So for that, the NIST has prepared lots of standards. For example, used catalyst, used toxic metals in urine, toxic metals in urine elevated, ocean sediments, environment, radioactive, urine trace elements, road dust, PG, CRM, like that. We have, at some of them, we have purchased. Even I had an opportunity to visit NIST in 2011, about 9 years back, and give a talk in the chemistry department. And after doing all this, the Bangalore, Hyderabad, Visakhapatnam, the sediments, the road dust samples have reported these values in comparison with Mumbai and Calcutta. Not so high, not very alarming, but it all depends on where you have, in fact, sampled. Generally, we try to sample from the high traffic areas only, but that keeps changing. Coming to the blood samples of the exposed persons, here you can see from different countries. Urine, a lot of data is available on urine, not much of data on blood. Urine, you can see in nanogram per liter, whereas in India, it is extremely very high, 150 to, so in blood samples, 650, 6,500 nanograms. And I will show you. So this PG accumulation is also getting increased with age of the police constable. So 25 to 30 years, you can see the y-axis. So here it is up to 3.5 ng per g, ng per ml, whereas 30 to 45 years, it is up to 8 ng per g, and 45 to 55 years and up to 25. So means there is a positive correlation of PG intake with age. And also high traffic areas are showing higher values and low traffic areas are showing lower values. These are some of the observations. And the traffic constables which got exposed to much of a traffic gave very high values of platinum, and with the background values of something similar to this, 0.098 ng per ml. On the other hand, 6.65 ng per ml of platinum and a similar value for palladium, which means the traffic constables are getting affected. And when you compare the traffic constable, general public, and the people who work in catalytic converter production, the workers, so they are also exposed in a moderate way. On the other hand, the traffic constables are exposed in a big way when compared to the general population. So these are actually my colleague, Dr. Kamala, published these results some time back. Hyderabad city, when we published some of these papers, immediately the TV9 approached some of the people, and then they made a big news. They made an half-an-hour program on this some time back, showing, and it was widely covered by a lot of other news media also. And what are the remedies now? So, for example, the major world cities are trying to ban diesel vehicles by another 5 years. So, air quality in Paris has forced political leaders to take hard stance on the use of diesel vehicles. The use of diesel in transport has come under increasing scrutiny in recent years. The mayors of Paris, Mexico City, Madrid, Athens are implementing the ban to improving the air quality. So as the number of vehicles are getting increased day by day, this problem is expected to increase manifold in future. In a bid to tackle such an eventuality, several governments, including US, UK, France, India, have come out with the plans to phase out diesel and petrol vehicles and replace by the environmental friendly electric cars by 2040. So another 20 years. Even recently, there was a big procession by the doctors of London to ban, they were urging the government to ban diesel vehicles. And on the other hand, a lot of research is also going on to make alternative, cheaper, and less harmful metals as catalysts to use instead of the expensive platinum, palladium, expensive and also harmful platinum, palladium. They want to use less harmful metals as catalysts in the autocatalytic converters. A lot of studies are going on. For example, Ames Laboratory in US have developed a method for making smaller and more efficient intermetallic nanoparticles for fuel cells application, which also use less expensive. Sometimes they are reducing the amount of platinum, and sometimes they are replacing the platinum. And so for example, Matthew et al. Have developed a highly diluted alloy of platinum and copper. Means platinum is used in a less quantity when compared to the general autocatalytic converters. And the Lofel et al. They have discovered an alloy made of 5 elements, which that is noble metal free, no platinum, no palladium, no rhodium, as active as platinum, where the high entropy effects result in catalytic activity for oxygen reduction that is similar to that of platinum. So very soon, cheaper, more efficient, PGE-free autocatalytic converters can be expected to replace the conventional ones. For example, this particular group from Germany, they made a noble metal-free catalytic system as active as platinum. Because again, the performance should not decrease. It should not be inferior performance. With the same performance, without platinum, palladium, and rhodium, these people have come out with a plan. So they published it sometime just a couple of years back. So now, not only this problem, but also the other problem of increasing carbon dioxide and the emissions of carbon dioxide by the several, for example, the thermal plants, and also we are cutting the forests. So as a result, the carbon dioxide concentration is increasing. So in order to reduce the carbon dioxide concentration, people are in fact fighting on the climate change, and we are experiencing increased frequency of extreme events. For example, just days before, we had a biggest rain never happened even in 100 years in Hyderabad. So that kind of eventualities people are facing all over the world because of the high concentrations of carbon dioxide and also other greenhouse gases like nitrogen dioxide, methane, etc., which are more potent than even carbon dioxide. So in order to reduce the emissions of those harmful gases and also the PG, people are coming with lots of plants and slowly phase out the petrol and diesel cars. Norway, Netherlands, Belgium, Switzerland, Spain will phase out by 2025. Germany, India, Israel by 2030. UK, France by 2040. And if everything goes well, by 2050, no emissions, only the battery cars will be, and also hydrogen fuel cars and also solar cars will be operating on the roads. And in future, hydrogen, when oxygen and hydrogen, they combine, they form water and release tremendous amount of energy. The emission is only water vapor, so which is totally harmless. So that is the kind of future we are going to have. So these are the trains which are going to run on hydrogen fuel, cars which are going to run on hydrogen fuel. Just like petrol bunks, you will have hydrogen bunks in addition to the battery cars. And somebody, Abhijit and Prashant Kumar, sometime back, they published a paper saying that it's not only trees, but also the hedges. If you plant across the roads, on either side of the road or in the middle of the road, they will reduce the harmful emissions. They will absorb the harmful emissions. Maybe this is also one of the solutions. And these are some of the papers. For example, the rare earth elements, the environmental effects of rare earth elements also have discussed in this paper, which I published in 2019, just a year back, and which has received 96 citations. And this is platinum group elements can be used to study, particularly the palladium can be used, palladium concentration in water can be used to understand the palladium potential in that area, platinum or palladium. PG mine in that area. And these are some of the papers related to this talk, which we have been publishing in the last 15 years. And this is the review which I published only this year. It has already received around 500 downloads. It's a book chapter, in fact, by Springer, Switzerland. And very recently, I published a paper in Microchemical Journal on NPAES. And just only yesterday, I received the galley, and there are some corrections, which is coming. It's everything about the elemental and isotopic geochemistry and geochronology. It's a 60-page, it's a very big paper. My 40 years of experience in geochemistry is going into that, which is coming in next week. Probably it will be available on the website of Geological Journal. And eight scientists from several scientists, in fact, some 12 scientists from 8 countries, like France, China, India, Portugal, Germany, Mexico, Colombia, Italy. We all combined and then collaborated to write a book chapter entitled Emerging Contaminants, Analysis, Aquatic Compartments, and Water Pollution. So this is one of the chapters in this particular book. This book is scheduled for the release in the second quarter of 2021, next year. So conclusions: discovering new environmental menace is faster than solving it. Everybody knows. And it is essential to understand that we do not replace one pollutant with another. So it is clearly evident that automobile catalytic converters are introducing huge volumes of anthropogenic toxic contributions of rhodium, platinum, palladium into the different environmental compartments, leading to human health issues. More studies are required to assess the ultimate fate and impact of these metals, aimed at understanding their behavior in subsurface environment, their pathway into the biota, and human health effects. High sensitive analytical techniques are available, but element specific biosensors, as I told you, that may become more popular in future. Urban planners also should plant hedges in combination with trees, rather than just relying only on roadside trees to most effectively reduce the pollution. Recycling is definitely one of the best options to minimize the environmental toxicity, not only for PGE, but also for several other toxic elements like lead, rare earth elements, and other elements. With many countries in the world over proposing to phase out petrol and diesel vehicles in the coming 10 to 20 years by introducing electric fuel cell and solar powered vehicles, this problem might be solved partly or even fully in future. Thanks a lot, sir. I once again thank Dr. Chandrachudan, Dr. Avinash Bharati, Dr. Raghav Sharan, Dr. Sriman Narayan for this wonderful opportunity. Thank you all.
Thank you, sir. Over to Preeti. Hello, Preeti.
Yes, sir.
Hello, Preeti.
Yeah.
Yes, sir.
I'm listening. Yes.
Yes.
Yeah, if there are any questions, we can take up few questions. For
I am Dr. Chandrachudan here. Hello.
Yes, sir.
Yes, yes, sir.
See, this particulate matter in air is a big problem in most of the cities, and the traffic population contributes to that very much.
Yes.
So, any specific studies were carried out for this particulate matter?
Not really, sir. We were only concentrating on PG even in this particulate matter. We used high volume samplers, and then from the particulate matter, we did not even separate the particulate matter basing on the sizes and all. We just made a total analysis of platinum group elements in the particulate matter.
Yeah. Because before this mask issue has become a popular thing due to corona,
Yes.
It was many people are wearing it while moving around in big cities.
In big cities,
Because of-
particularly Delhi. Yes,
Yeah, yeah.
yes.
Yeah. Thank you very much. Very nice talk. Thank you very much.
Thank you, sir. Thank you.
Sir,
Yes.
can I ask?
Yes,
Upendra
yes,
Singh.
yes, sir.
Right.
Yes.
Upendra Singh.
Yes.
Sir, Dr. Balram,
Yes, sir.
sir, thank you so much for a very nice presentation and with a very good information to us. I am Dr.
Thank you.
Upendra Singh, working as a principal scientist and heading analytical division in Nagpur. One institute is there under Ministry of Mines, that is called Jawaharlal Nehru Aluminium Research Development and Design Center.
Okay.
Sir, I have a small query. I don't want to ask any question. Recently, we procured one ICP MS, that
Yes.
is the Nexion 2000 from Perkinhammer.
Okay.
Now, this machine is normally we call as, we can't say it's a high resolution ICP MS, but in NGRI normally refers as a HR ICP MS.
Yeah,
Can
yeah.
you just give in small some some lights on difference between the HR ICP-MS and normal ICP-MS?
Yeah. I understood your problem.
Yes.
In fact, when we procured the ICP-MS for the first time in 1987, we
Ji.
procured a quadrupole ICP-MS, just like what you have procured.
Yes.
So the high resolution ICP-MS is a magnetic sector ICP-MS. The quadrupole ICP-MS will not have resolution, good resolution power. Any interference, no, you cannot really eliminate.
Okay.
Whereas the high resolution techniques using the magnetic power, magnetic sector instruments, they will have. I showed you one spectrum.
Yes.
See,
Yes.
platinum and hafnium oxide.
Ji.
Both are 190.
195 mass.
195. In your machine, no, it will be a single peak.
Okay.
You cannot separate them. Whereas in a high resolution ICP-MS, there will be two peaks. So you can clearly separate and do a non-interference determination.
Yeah, that's what I was little bit confused to whether it is a resolution based on the mass or based on the concentration or so.
No,
Because
mass.
Because if there are a adjacent mass, then separation will be little easier in magnetic sector rather than other than this.
But you see, quadrupole ICP-MS is also equally powerful.
Ji.
But we should know which isotope has to be used for a
Yes,
interference-free determination and what
But
kind of
now they are-
precautions.
Yes, now they are claiming, and I think they are also claiming that it is equally like magnetic sector, a bit triple quadrupole and like that.
Yeah. You got a very good point. There are actually collision reaction cells in that. If you
Correct, sir,
if you
correct.
use a proper collision gas or proper reaction gas, some
Ji.
of these, for example, hafnium oxide, you can eliminate hafnium oxide by getting a reaction with a gas, so that only platinum peak will come.
Okay.
So that kind of things are also possible, and that's what I'm telling you. Even the quadrupole ICP-MS is also equally powerful.
Correct,
I don't
sir.
deny that. Yes.
Right. Now, because there are a number of modes now had come like standard, dynamic, and then DRC, and all those things are.
One should understand how
Ji.
to eliminate a particular
Correct.
interference.
Sir, thank you so much, sir. It was very nice, sir. Thank you so much.
Thank you so much.
There's a question from Sachin Vazalwar. We can have the question from Sachin Vazalwar.
Yes.
Thank you, madam.
Presentation.
Hello.
Namaskar, sir.
Namaste.
Can I stop? Yeah. Namaskar.
Namaste.
Can I
Namaste.
start?
Hello.
It's not getting stopped.
Namaste. I'm able to hear.
Yes, sir.
Okay.
I am into ambient air quality monitoring for last 11 years, and
Okay.
my question is, the research institutes are exhaustively analyzing the things, analyzing the scenarios and source of pollution. But the real problem where it lies in implementation is that in our pollution control board, state pollution control board, they deal with the industrial pollution only, and they do not deal with the pollution due to anthropogenic activities and also due to pollution due to vehicular activities.
Yeah,
Like
you
they
know.
don't have a mechanism to penalize the domestic coal burning, the vehicles emitting or violating the norms, and they
Yeah.
just deliver an advisory, or they just put the advertisement for awareness, but they don't have a mechanism to penalize. I don't know whether the same is the scenario in the acts of other state pollution control
No, no,
board,
no.
but
In
it is
other
there in
countries
Maharashtra.
also the same
What is
problem,
the sense?
sir. It's not only you. Everywhere it is the same problem. Nobody can control a vehicle. And on the spot, you cannot analyze that it is emitting a PG or not. What kind of a pollutant it is emitting, you cannot.
No, no,
It's
no.
beyond anybody's
Not
control.
about analyzing only, but also they don't have anything like controlling the domestic coal burning.
Yeah,
As of
domestic coal burning.
the coal is
Domestic coal burning.
the coal excavation is strictly
Maybe
for
you
industrial
can.
purpose.
Yeah. Domestic coal burning. Maybe we can stop. And once in a village or in a small town, if you are able to successfully stop them, then and penalize them, then automatically. But in a country like India, no, it may be difficult. I don't know.
But I have been following this, and I have been asking the agencies for last 10 years.
Yeah.
But what the MPCB says, State Pollution Control Board, that it is not our jurisdiction. The corporation should handle the issue if it is in the jurisdiction of corporation. The
Yeah.
corporation says we do not have any mechanism to deal with individual pollution.
Yes.
Those are the issues. I am dealing with this
Yeah,
for
now
last 11 years.
the
There is
same
no
kind of a
mechanism to
thing is
implement.
coming in Punjab, where the grass is being burnt in a very large scale, which is polluting
Yes.
Delhi. So there's something similar to that. That's a much
Yes.
bigger problem than domestic coal burning. Okay, thank you.
Hello. Hello,
Yes.
sir. Good evening, sir. Hello.
Yes, sir. Yes, madam.
I'm Namrata Chaudhary, sir, from Nagpur, GSI.
Yeah. I
Good evening,
remember.
sir. Very wonderful talk
Thank
on
you.
this road dust. We are dealing with the geological samples for Fiji analysis, right?
Yeah.
And we are having the normal mode ICP-MS of Perkin-Elmer, as Upendra Singh sir told. Right. And
Yes,
for
yes.
this study, sir, HRICP-MS is required along with the high matrix introduction technology. And
Not really,
Yeah.
Dr. Namrata.
Yeah.
Actually, if you have, I'm sure that you have the reaction and collision mechanism also.
We are.
Yeah, if you, I'm actually currently writing a paper
Hmm.
on these aspects only. How
Yeah,
best we can eliminate these interferences.
Mhm.
uh,
So is
of
it
different
possible in
elements,
collision
including
reaction
PCE.
cell, or that ammonia gas is required, or helium with KED mode is required for this
There are,
at
you
PPT
please send
level?
a mail to me. I will forward a number of papers on this particular. You can do you can draw best data from the quadrupole ICP-MS
Okay.
using
Because
collision
at this
or
PPT level, sir, this matrix interferences are very much there, no?
no.
And,
You can do that. You can
one more.
by using the collision and reaction cells, and
Yeah.
you need to choose that particular gases.
Yeah.
Then you can eliminate.
Acha. So
Yeah.
we are using methane gas in collision reaction, sir, right?
Right now, I don't remember how. But
Yeah, we are
I,
using.
yeah, I can forward some good papers.
Yeah.
You just
Yeah,
forward a mail to me.
it's good for me, sir, if you are sending such type of papers. And
Yeah.
and one more thing, sir, at this PPT level, we are always doing this nickel sulfide fire assay for a pre-concentration technique before instrumentation. So for this dust sample, how much volume of sample is required for this?
Dust samples, even 2 grams will give you repeatable values, because the material is very homogeneous. No?
Yeah.
Even 2 gram, 1 gram. See, sometimes you may not be able to collect 1 gram dust also. It's very difficult.
Yeah, that is very difficult.
Very
No, sir,
difficult.
that's what I'm asking.
Whatever amount of dust you get, we used to analyze. So you cannot set a kind of a targets for the amount of dust. It's very difficult.
So is it possible with 1 gram with nickel sulfide
1 gram,
fire assay?
yes. 1 gram. These dusts are very uniform, very homogeneous.
Acha, homogeneous, right?
Yeah, that's why Even sometimes even 0.5 gram, you get very repeatable
Right,
values.
right. That nugget effect and all is not
All
will
that
be there.
are not there. Yes.
Right, sir. Thank you very much, and
Thanks.
I'll
Thanks a lot,
forward you the
madam.
mail,
Right.
sir, in future also.
Right.
Thank you, sir. Thank you.
Good evening, sir. May I speak a question? I am Dr. P.K. Jain.
Yeah, Jain from IBM.
Yes, sir. Good evening, sir.
Oh, how are you?
Fine, sir. Fine. And compliments for giving a such nice talk. And we got the opportunity to see you live. And I have one very small question. I am actually Dr. P.K. Jain, Chief Mineral Economist in IBM.
No, you are a big man, I know. Don't worry.
Sir, we are preparing the National Mineral Inventory for the PGM mineral also.
Right, right.
So just my question is, what should be the minimum level to put up that figure in the inventory? What are the any international references are there? Because whatever the data we are getting, like a chromite, nickel chromite dumps, so PGM is coming as a
you mean for PG mineralization? You mean?
What is the minimum count should be there to keep the figure in National Mineral Inventory to say that these are the resources available in the country for the PGM?
Yeah, this is a difficult question at the moment. In fact, we have proven deposits. We really don't have a proven deposit. There are some which the private mining companies have proved, like Geo Mysore and all. Generally, of the order of ppm.
So whether we will call it as a resources or not?
1 ppm, 2 ppm, even 0.5 ppm,
correct,
0.3 ppm, you can call as a kind of resource, to my knowledge. And also it's difficult. And also how much body, that is more important. See, the body, how big, the ore body, even if supposing you have 0.25 ppm, it's a huge body, then it's a big ore.
Okay.
So it all depends. So we cannot really make a general statement.
Okay. Thank you, sir. Thank you.
Right, right. Thank you.
Any other question? Right. So,
yeah.
I'd like to request
Yeah, good evening,
sir to felicitate Dr. Balram for his excellent talk by presenting him with Certificate of Excellence.
No, I think let's not take much time because there is another seminar is going to come. Let us finish as early as possible. Okay, thank you, thanks a lot.
I would just read the citation. Indian Society of Analytical Scientists, ISAS, Nagpur chapter and Tamil Nadu chapter jointly confer the Certificate of Excellence in deep sense of appreciation on Dr. V. Balram for his immense insight, unparalleled expertise, and knowledge enrichment by sharing his valuable work explored over 2 decades and excerpt from the book, Handbook of Environmental Materials Management, etc. as the guest speaker in an online webinar held on October 17, 2020.
Thanks a lot, sir. It's a sweet memory for me. In the
immense realization of the objectives of the society. Thanks a lot.
Thank you, sir. Thank you so much.
Before I hand over to Dr. Arun Kumar sir to propose the vote of thanks, just an information for the participants that the feedback link is pasted on the chat box, so you can give the feedback for the webinar. Now, I would like to request Dr. Arun Kumar Singh to propose the vote of thanks.
Hello, madam. I am Dr. Arun Kumar Singh, Assistant Professor in the Department of Mechanical Engineering, NIT Nagpur. Good evening, everybody. It is my pleasure to propose vote of thanks on behalf of Organizing Committee of Nagpur and Tamil Nadu chapters of Indian Society of Analytical Scientists, ISAS, for making the special online session a reality. First of all, I would like to thank Dr. V. Balram, today's distinguished speaker, a worldwide famed ICP mass spectroscopist, for delivering the excellent talk on impact of platinum group elements in road, dust, soil, and waters of major world cities and their impact on the environment and human health. This talk is the result of decades of dedicated works of the speaker and his team. The dedication is highly inspiring to all the scientists. Thank you, sir, for the lecture.
Thanks.
I also thank Dr. P.P. Chandrachudan, National President of ISAS, Dr. Raghav Saran, Advisor Nagpur Chapter, and National Vice President of ISAS, Dr. S. Sriman Narayan, Chairman ISAS Tamil Nadu Chapter, Dr. Avinash Bharti, Chairman ISAS Nagpur Chapter and Convener, for their sincere efforts to realize the webinar during the time of pandemic. I also acknowledge the contribution of other members of the organizing committee, especially Dr. Chandrasekhar Pandu Nerkar in formatting feedback forms, e-certificates, etc. Dr. Preeti Mangrulkar for efficient comparing, Dr. Indrani Dasgupta and Dr. Sarup Lakshmi Mudliar for technical supports, and special thanks to Shreya Bharti and Akshata Bharti for technical and all kinds of support as and when required. I am also grateful to all the life members of Nagpur and Tamil Nadu chapters for their mammoth support and participation. And last but never the least, jewel of our webinar, our dear participants. Besides, I must appreciate to each one of them who has rendered his or her support directly or indirectly in making this webinar a great success. Looking forward to similar participation and interaction in future as well. Thank you all.
Thank you.
Yeah, thank you.
Thank you all for active participation. I am sure we will see you all again in another interesting webinar soon. So the link for feedback is pasted in the chat box. Thank you.
Thank you.
Thank you all. Thank you.
Thank you. Thank you.
Thank you,
Thank you,
Dr.
sir.
Balram. We are highly elated and we are highly enlightened.
Thank you, sir.
very
Thank you
much.
so much. It is because of you, your
Because
initiative.
we are having
Thank you.
another webinar.
Thank you,
also.
sir.
We
Thank
are
you, Dr.
trying
Balram,
to-
sir.
Thank you.
Thank you, Balram, sir.
Thank you, sir. Thank you, Dr.
Thank you, sir. Thank you, Dr. Balram. Thank you. Thank you.
Thank you, Dr. Sivan.
Thank you, sir.
Thank you.
Thank you, Arun Kumar, sir.
Thank you. Thank you very much. Thank you.
Yes.
Okay.
Good night, all. Saran, sir, should we?
Shall leave now?
Yes, sir. We have to again join another webinar. Yes, sir.
Yeah.
Should we leave? Okay, sir, we can leave now. Okay. Thank you, sir.
Okay. Chandra,
Dear
good evening.
participants, you have to fill the feedback form. Before leaving, fill the feedback form. Dear participants, fill the feedback form.
पूछ लो हमने क्वेश्चन है हम लोग संग गए थे ना झांसी गए थे ना जहाँ कह रहे यू आर ए बिग मैन सुना हमने हाँ डॉक्टर जैन यू आर ए बिग मैन झांसी में